Okay, all right. So today we're going to go over some of the region's questions on rates of change, which was based on the lesson from yesterday. Okay, so yeah, let's get started. Okay, all right. So here's what we're gonna do. So I looked at the list of questions that I had, which were 14 of them, and there's just no way we could do 14 questions. Not that we couldn't. We could do 14 questions, but it would end up taking like close to 50 minutes for you on your end to actually do them and finish them. So here's what I'm gonna do. I picked the 7 questions that I like the most, that I think is most useful for you. And if there's time left, maybe I could do 1 or 2 extra questions. Okay? So here we go. Now, focus on number 2 right now. Okay, just number 2, because you can't see the rest of number 3 anyways. So try this right now. Okay, so take a couple of minutes. If it takes you longer than 3 minutes, you're probably taking too much time, okay? Because there's a faster way of doing this, okay? I'll give you a hint. Just look at the graph. Look at each of these segments of the line, right? And think about which one would have the slowest rate of change, okay? So try that. All right, so press pause right now. Okay, and we're back. By the way, so we're gonna have to go over these questions one by one because the questions, they're very graph heavy. So if I try to squeeze everything into one page, you won't be able to see any of the numbers of the graph. So that's why it's also taking a little bit more time. Now, this question here, okay, involves 2 parts. One is you need to recognize that for a line like this, let me use a highlighter. For a line like this one right here in the pink, look how fast this line is dropping, right? So look how steep this line is. Look how, I was gonna say slopey, but that's not a real word, right? Look how steep the slope is. There's no way that that's gonna be the slowest, right? Now, second thing that I looked at was also this one. This one's the same thing here. It's a little too steep, at least compared to these 2 lines here. Let me use a different color. At least compared to this right here and this right here. So I thought, okay, I knew that this was a little bit flatter on slope than this one, but I just wanted to prove it to you. So here's what I did. I took this to find the rate of change. So I did change in y, which is 20 minus 19, and then 10 minus 5, and I realized that was 1/5. And I knew that that was probably good enough, but I just wanted to make sure. So for this second one here, right, I did change in y, right, the second y, 17 minus 14, and then 20 minus 15, that's 3/5. So I was proven correct that 1/5 is the smallest. Okay, so that way it saves you a little bit of time. You don't have to do this 4 times over. Okay, remember again, right? Regions questions, high school questions, efficiency. All right, always try to be efficient. Okay, so try number 3 right now. All right, and yeah, okay, all right, so press pause right now. Okay, all right, here we go. So for this one, it's more or less the strategy is the same as the last one. So what I did was this. Now, here they want the greatest rate of change, right? So I immediately look at the steepest lines, the biggest slopes, right? And I realize that these 2 at the end, that's not it, okay? Like, they're just not it. So I cross those out, okay? And then, hold on. And then, right, I start looking at these 3 because I know that these 3 lines, and I highlight them in yellow, pink, and green respectively, that they look like a straight line, but I knew something was up. I knew that it wasn't completely flat, okay? So I looked a little further. Now, I looked at the choices. The reason why I cross out the green highlighted part here is because this wasn't even offered as a choice. So I'm not even gonna do any calculations on that, okay? So this is where you would have to work smarter, okay? And so let's see. Oh man, what was I doing? What am I doing right now? Okay, so the way I looked at it was, okay, let me just examine these two then, right? The yellow part, which is the math here, right? So I did 700 minus 200, 1 minus 0. So the rate of change there is 500. And then I looked at the little pink part here, right? And that's 900 minus 700, and then 1.5 minus 1. And it turns out this was slightly faster. This is 500, that's 400. So that's why I picked the first choice. Okay? All right, let's see. Moving on. We're not doing this one. Number 5, all right? So, all right, voting rates in presidential elections. Okay, all right, how appropriate. All right, so try this one. The only thing I would say is before you start is that there are a lot of lines going on here, right? So you got to be careful. Okay, when you look at like choices like 18 through 19, you got to make sure you're looking at the right lines. Okay, all right, so press pause right now. Okay, all right, this one took me a while because the reason why I thought this question was tough is because like for each one of these choices, you have to hold on to so many pieces of information at the same time. Like it was like an exercise in like how much short-term memory I got left. All right, in my 42-year-old brain. So, number 1, all right, now here it says does not correctly. So you see how I wrote true and false here? Okay, now, let's go backwards, okay? The voting rates of eligible age groups between 35 and 75, the percentage, right? Now, that is true because 39 to 72, let me use a highlighter, much better, right? 39 and 72 is between 35 and 75. So that is true. So I wrote true, but that means I have to cross the choice out, right? About 70% of people 45 older. So I go to 2004 election. 70%, that is true, right? 45 and over, right? And that's true. Okay, so I eliminated that. And then I looked at choice 1. Choice 1 was slightly tricky. All right, so for citizens of from 18 to 29, this last line here, the rate of change was the greatest between 2000 and 2004. So I'm looking at this. So they're saying this. Is that the greatest? Yeah, probably. Right? Compared to this line, I know what some of you are thinking, well, they're so close, but here's the thing. I mean, the other thing that as soon as I saw that, I was like, okay, I'm not sure, so I put a question mark there, okay? So I'm showing you some test-taking strategies here. The last thing was, okay, I wanted to make sure that then choice 2 was absolutely not the answer, and if I can't prove that, then that's probably the choice. So so what I did was this: from 96 to 2012, so the span of the study, the average rate of change was positive for only 2 age groups. So I thought, okay, how can I figure that out, right, without crunching any numbers? Because the problem is there's nothing wrong with having numbers here. Look here, there are no numbers here. Like these points don't have exact numbers. So the moment I saw that, I realized, oh, like I have to rely on like looking at the graph itself. I can't be reliant on numbers itself. So, okay, so what I did was this, all right? I actually just drew very thin blue lines and just to see if it's going up and going down. Now, in retrospect, I didn't have to do that. Why? Because the numbers at the beginning and end are actually given. So for 18 to 29-year-old people, right, the numbers went up, right? Went from this to this. For the next group, for the next age group, it went up. And then for this one, it went down. And then for this one, it went up. So that's not true. It's not 2 age groups. It's 3 age groups. Okay, so that's why I picked that as an answer. Okay, because we're looking for the wrong answer. Okay, all right, okay, so moving on. Now, number 6. Okay, so try this one on your own right now. Okay, this one I think I'm better off going over with you because if I start drawing all of these together, you might not follow. So now, again, this test, all right, is quite brilliant in my opinion, because now you have to, like, it always question as to whether what's more efficient for you. Do you actually crunch the numbers, or do you look at the graph and then figure out where do you actually need to start crunching the numbers? So I think this is really well written. All right, I think the regions is like an awesome test. Okay, now, so which years did it change the most per unit? So I was thinking, okay, all right, I need to look for the steepest lines, right? Positive and negative. So the moment I looked at, I knew that this was the one, because think about it, right? And I'm gonna draw it out, but this is tricky because I gotta draw out really thin lines. This is tricky because look. Let me see what's oh, you know what? Let me use red. That's the best. That stands out the most. Okay, so look, right? From here to here, right? Think about it, right? Rise over 1 is 3 to 1, right? This was 3 to 1. Here, look, you can just count boxes, right? Look, this is 2 over 1 up, right? Actually, I should use the other side, right? 2 up, 1 over, 2 up, 1 over. What did I just do? Right? 1 over, 2 up, 1 over, 2 up, and 1 over. So originally, I thought all the members of this line right here, I thought all the members of this line right here in the pink, right? I thought they were the contenders, all right, to this one right here, right? Because like they both look pretty steep. But upon further inspection, this is steeper because this is 3 over 1. Okay, I don't know why I just did that. All right, this is a little frustrating. Okay, right, so this was 3 over 1, right, or 3. These are all 2 over 1. So that's the change. So let's see, how do we answer this question? Which years? It was from 1960 to 65. Explain how you determine it. Basically what I just told you, right? Between this and this, the greatest rate of change here is 3 to 1, and this one is only 2 to 1, okay? And you could use slope, okay, if you want to, in your answer, okay? How are we doing? Okay, all right, 7. We might have to stop at what? How many do it? 7, 9, 12. Okay, all right. Let's make a goal for it. All right, 7. All right. So try 7 right now. So press pause right now. Okay, all right. So the more I look at this question, the more frustrated I got because it's like this question's got like 4 parts to it. Okay. It seemed like there's only 1 question, but there are actually 4 questions. Now, I can't say this enough. I think it would be of immense benefit to you on the Regents exam if you have access to a highlighter. I think like, you know, knowing what I've been doing with you guys today, like I think you guys really need a highlighter. Okay, I think you have to have it. Okay, all right, now let's see. What's the appropriate domain? He thinks integers should be. Why is integers not an appropriate domain for the model? Yeah, because time is continuous, right? Now, if you really want to score more brownie points, time is a continuous function, right? Okay, 2. State the entire interval for which the pairs of shoes is increasing. So what I did was I just connected this with a big blue line. Okay, so from t equal to 0 to t equal to 6, right? The function is increasing, as you can see right here, right? So that's my answer here. 3 is I have to find, I mean, look at this, like 4 parts. I have to find between 6 hours and 14 hours, so I just wrote down the points, right? Please do that. And then I did 0 minus 120, 14 minus 6, right? So, and then I figured it was negative 15 pairs of shoes per hour, and then explain what it means in the context, meaning, right? This is how you can explain it. You can explain that the rate of change in the shoes shoe sales per hours is decreasing from t equals to 6 to t equals 14. Okay, you can say it like that. Okay, all right, next question. Let's see how we're doing on time. Wow, we're getting close. Let me see, I might have to make a sacrifice. You know what, 9 is really important, and then I'm gonna have to let 12 go. All right, let's try 9, and then the rest of these, let's try to do it in class, okay? So don't worry too much about it. Now, for this last one, the only thing I gotta add is the fact that this is x and this is y. So, and the reason why I remember and I thought to tell you guys this is because even on the 7th grade state exam, when you guys start seeing these tables and you have to find the unit rate, am I right? Right? Remember how to find unit rate? The unit rate's represented by the letter K, which is always y over x. So that's why when you are calculating the rate of change, notice all these numbers. Notice how all these numbers, right? They're all like more than 1, right? So that means it's always y over x anyways. Okay, so press pause right now, okay, and do this question. So press pause right now. Okay, all right, let's see now. Yep, knowing that, right, now here's ask you for the original photograph, so you see how I circled the first one, and I wrote the point, 0, 15, right, x comma y, and same thing for the last one, right, 4th enlargement. And then they want to know the rate of change, so I did that. By the way, notice how I keep rewriting this over and over, okay, because whenever I write this, this is just me, all right, I just feel more like I know what I'm doing, okay. Now I know I'm the math teacher, like, but even, you know, as a math teacher, I always feel like if I write this, then I'm like 100% sure what I'm doing, okay. And look at how I'm showing all the work, right? So one last thing before we go, I want to add one more thing to this, all right. Integers is also not an appropriate domain because integers includes negative numbers, right? So you can't have negative time. Okay, and then lastly, in the context of the problem, right, he's selling 15 less pairs of shoes per hour. Okay, so all right, with that said, okay, this was a little bit long, but I gotta get these done. So all right, okay, thanks for watching, have a good day, and I will see you tomorrow. Bye-bye.
OMG, that was so good.